yeah, they could join there. There's also a YouTube link. I'm not sure where it's going. All right. So, with respect to the PDF you sent me, right? So, let's just take a look. So the first page had some indices, well, plenty of indices, with varying degrees of difficulty, right? And then we had some surds on this side. And then we had, what's this point? Computing the square, max minimum point, discriminant stuff. You mentioned discriminant on Tuesday, right? I think I remember that. There's one alpha beta question. Find the quadratic equation with roots alpha squared and beta squared. That's interesting. All right, no problem.
Yeah, I think.
Uh-huh. All right, so the hidden quadratics is item D here, right? So what we could do, we could use this page as the examples, and I could always pull from the text if you guys want to do more in that thing. We have some inequalities here. So we have two quadratic inequalities. We have two rational inequalities. And then we have calculus, differentiation, and the next bit is integration. So, okay, so where you want to start then? You want to start with those things you mentioned, the hidden quadratics? All right, okay. And Luna, what about you? You just want to work through it piece by piece? Oh, okay, cool. So you will work. I'll sort that. I'll just kind of bounce back between both of you. All right. All right. So, okay. So let's just head up page 1. Yeah. So the correct term for this is equations. Oh, sorry. It is blank out. Okay, hold on. Give me 1 sec. I'm not sure what an equal. There's a little contact point problem. It should pop back up very soon. There we go. Right, back in again. Right, so equations reducible to quadratic form. So let's see. Yeah, 6 or 1/2 of this. So equations reducible to quadratic form. Okay, so we know that a quadratic equation has a kind of generic form of ax squared plus bx plus c, right? And you can put it equal to 0 if you want. If it's an equation, let's do that, equal to 0, right? Now, what I want you to observe here is the progression of the powers of x. What power is this? That's 2, right? There's no power explicit here. So what power is understood? 1. Correct. Right. Now, and then there's cool. Okay, cool. And then there's no x term there at all. But technically, you can put x to the power 0. But that's not important, not relevant to what we're doing, right? What we do need to observe is the relationship between the powers. What I mean by that is this power here is always 2 times. So this power is 2 times. Sorry, that's an n. Right? Or double that power. So what that means is that if we have any other equation, for example, let's pull this one here. So x plus 9 root x plus 14 equal to 0. So let me write it out. All right. So let's say we have x plus 9 root x plus 14 equal to 0. Right. So let's rewrite this equation, that the left side of that, with powers, because again, there's no power explicit here. So what power is understood? 1, right? So we have x to the power 1. The square root of x can be written as x to what power? X to the power of 1/2. All right. Now, what about these two powers here? Is the relationship between 1 and 1/2 the same as between 2 and 1? If we take a half and multiply it by 2, do we get 1? Let's take a look. So 2 will cancel with 2 one time, and then 1 by 1 is just 1. So yes, so the same relationship exists between these two powers as it does with these two. Now what that means is that we can reduce the equation to quadratic form. Now what does that mean? Right, so what that means is we could make a substitution. We could say, let x to the power of 1/2 equal to, now usually we just choose y. It's the kind of easiest. We could use y, you could use a, just don't use e or o, because those are, or I. All right, e and I are very specific, have specific values in mathematics. All right. Sorry, 1 second. Right, give me a minute. I have to just have to. This one. Oh, cool. Okay. Sorry, yeah, so we're going to let x to the half equal to y. Now, why would we do that? Well, that's because what we could do is we could then rewrite this equation like this, right? Now, what it also means is that x to the power 1 is equal to x to the power of a half to the power 2. Seeing Amelia. Evening, Amelia. How are you doing?
Hi, Mary.
All right, good to have you on. We're doing some work from the what you call it, this worksheet that your teachers gave you all for Art Math. So I have Shalmaris on with me. I have Luna in person. So Luna working to the paper from the top go down. So what Shalmaris asked to work from this item here, so the disguised quadratics. All right. So that's what we're doing for now, and then we might have some more sessions as we go along. So you're welcome to stay, and you're welcome to ask any questions you have about Art Maths. All right, cool. No problems. Right. So so like I was saying, x to the 1, right, is x to the half squared. Now, when you have a power in a bracket and a power outside a bracket, the law of indices that governs that tells us that we do what with the powers? We have to multiply them together. And we just saw that a half multiplied by 2 is equal to 1. So what that allows us to do is to rewrite this equation like this. Y squared plus 9y plus 14 equal to 0. All right. Jean-Marie, you follow me on that one? All right, you have any questions at all? All right, cool. Yeah. Amelia, I know you're just popping, but you have any questions or you're okay with what I have so far?
No, I'm good.
All right, cool. All right, so now we factorize. All right, so factorization can be done a long way or a short way. Project 2, cool. This is Form 4 Art Maths. Hey, Samara, how you doing? Good to see you on. Sorry, one of my past students just on the TikTok. Right. So when the coefficient of the squared term is 1, it's pretty easy to factorize, especially when all the terms are positive, right? So we know we can put y to the front here, and we're looking for 2 factors of 14 that'll add back to give us 9. Now the factors of 14 are pretty limited. You have 1 by 14, and you also have 2 by 7. Which of these pairs will add back to give us 9? 2 and 7. There you go. So 2 and 7. Right. And of course, you could always cross-check it. So y by y is y squared, y by 7 is 7y, 2 by y is 2y, and 2 by 7 is 14. And if you add the 2y and the 7y, you get back 9y in the middle. Of course, feel free to do the full-fledged form of the factorization. Right. Now we come to an interesting statement here. What's the understood operation between these two brackets? Multiplication. And the statement is telling us that when we multiply these two brackets together, we get 0. There's only one way to get 0 when you multiply. You have to multiply by 0. So because y is a variable, its value can change or vary, we have to consider each of these factors equal to 0 in turn. So either y plus 2 is equal to 0 or y plus 7 is equal to 0. Now, if y plus 2 is equal to 0, to solve for y, you'll subtract 2 from both sides of the equation. And across here, same thing. You'll subtract 7 from both sides of the equation. Now, we're not done because remember, we made a substitution up here. But we let x to the half equal to y because the original equation is this, right? So we want to solve for x. So what we have to do now is kind of undo the substitution. So if x to the half was equal to y, and we have two values for y here, we're now simply going to replace y with x to the half. All right, so we have now x to the half is equal to minus 2, and x to the half is equal to minus 7. Right, now, of course, x to the half is the square root of x. So if the square root of x is minus 2, how do we undo a square root? To undo a square root, we simply have to square both sides. When you square the root of x, you're going to get back x. And when you square minus 2, so what happens when you're squaring a number? You multiply it by itself. And when you multiply a negative by a negative, you get back a positive. So minus 2 by minus 2 is positive 4. Sitting across here, we have the root of x is equal to minus 7. And when we square both sides, we get x is equal to 49. Right? That is how we solve this type of, well, this equation, which is reducible to quadratic form. Right? Now, again, this could be done once you have, well, you can have two terms, but technically speaking, right, once you have three terms, and the power of the algebraic terms, the powers are related by, sorry, the relationship between the powers is that the bigger power is double the smaller power, right? So again, in a regular quadratic, the biggest power is 2 and the smaller power is 1. And of course, 2 is double 1, is 2 times 1, right? Across here, 1 was 2 times or double 1/2. But of course, those aren't the only numbers with that same relationship, all right? So quick question. So Shamri, you want to do another example with one of the others here, or you want to try one with the square root one time? Or to undo it at the end? Okay, cool. All right. So you want one to practice, or you want just to go to the rest of them? All right, cool. All right. So at some point, I will give you some sort of practice as I have to go and correct some work with Luna, right? All right, cool. All right. So let's do. Hold on. All right. And Amelia, how are you? How are you with this one here? Any questions on how I finish it off, or you good?
Yeah, same thing with me.
Or to undo it at the end? Yeah, that's a common mistake. Don't worry about it. I used to do that all the time too. All right, but the only way to get better is to practice making mistakes and then learn from them. All right, so no worries. All right, so let's do our next page. Page 2. Okay, cool. All right, so the next question was what? 2x plus 1 is equal to 21 over x. Oh, that's an interesting one. All right, so 2x plus 1 is equal to 21 over x. All right, 1 second. Huh? All right, so first things first is we're going to multiply throughout the equation by x to clear out the denominator on this side here. Right? And you have to multiply everything by x. So of course, 2x by x will give us 2x squared. 1 by x is just going to give us x. And 21 over x multiplied by x will give us 21. And then what we do from there is we subtract 20. So you bring it across and change the sign, or as I prefer to say, you'll have to subtract it from both sides. Right? And now we have, regular old quadratic. So nothing too exciting. All right. Now, the other way that you could have done this is that no. Yeah, I was gonna say maybe write this as 21 to the by x to the minus 1. Yeah. Yeah, now because you see the power here is 1, and the relationship between them would no longer be that the bigger one is 2 times the smaller one. So if that relationship is non-existent, then you can't reduce the equation to quadratic form, right? So in this particular case, you just ended up dealing with a regular quadratic. Sorry. Right? So of course, what we have to do, we have to multiply 2 by 21. So we are looking for the Now you could use factorization, or if you like your formula, you could use the formula too, right? So factors of 2 multiplied by minus 21, that's equal to minus 42. So what are our factors of minus? Well, what's 42? So that's 1 by 42. We could use the same 2 and 21. Now 4 and 2 is 6. So we know it's a multiple of 3. 3 by 14. And of course 6 by 7. Now when we have a negative product and it's 2 factors, the only way to get a negative product when you have 2 factors is if one factor is positive and one factor is negative. In other words, you have to have opposite signs. The question then becomes, okay, how do we know which factor to make positive and which to make negative? And that is actually quite easily answered. Whatever sign the coefficient of the x term has, the larger term takes that sign. Because remember, we're going to split this middle term using the 2 factors, right? And of course, the smaller factor takes the opposite sign, right? And which of these pairs will give us back, well, plain old 1 when you add or subtract? Well, clearly not this. That's going to give us 41. 21 minus 2 is 19. 14 minus 2 is 11. And 7 minus 6 is 1. So there you go. So we could, sorry, Jonathan, could you do the Add Maths Paper 1? Yeah, Add Maths Paper 1 2025 will be done within the next few weeks. I'm finishing up some form for you guys. All right. So we have 2x squared. Now it doesn't matter if you put the minus 6x or the 7x first, right? If you do it this way, you could kind of factorize a bit more easily, right? So because between 2x squared and minus 6x, you could use 2x as a common factor. When you divide 2x squared divided by 2x will give us back x. Minus 6x divided by 2x is simply minus 3. And between 7x and 21, there's no common algebraic term. So we use 7, right? Because 7 is common to 7x and 21. When you divide, you're going to get x and then minus 3. Because you're dividing each term by the common factor. And of course, if you were to reverse it, expand, you should get back that. Okay, and now we observe that the binomial expression is the common factor. So when you pull that out and divide, the coefficients then go together in a bracket at the back. From here now, we come to the same point we got in the last question when we got to here, right? We're multiplying 2 things and the answer is 0. The only way to get a product of 0 when you multiply, regardless of any number of factors, is if one of the factors is 0. Just 1 second, Jonathan asking a question. Thoughts on the paper 2? Actually, it was a decent paper. It started off kind of shaky, to be honest, but the later questions were actually quite doable, Jonathan. Yeah, so I have to do a full breakdown. I put a few questions on TikTok. Ones that you could work real quick. You could always check it out. Right. Anyway, right. So again, because x is a variable, its value can change or vary. We have to consider each of these factors equal to 0 in turn. Right. So if x minus 3 is 0, so that's pretty simple. Some number, you minus 3 from it, you get 0. The only number you can minus 3 from and get 0 is 3. Now 2x plus 7, you have 2 things. So first things first, you're going to remove the plus 7. How do we remove something attached by addition? You have to use the opposite operation. And the opposite of addition is subtraction. So we're going to subtract 7 from both sides. Again, just showing it a long way, just in case anybody didn't know. So 7 minus 7 will be 0, leaving us with 2x on the left-hand side. And 0 minus 7 is itself minus 7. Now to solve for x, you have to remove the 2. How is the 2 attached? Multiplication. How do we remove something attached by multiplication? We use the opposite operation, which is division. So again, you could show it explicitly, or you could just do it kind of mentally. So x is equal to minus 7 over 2. And that's it. We don't have to make we don't have to undo any substitutions, anything of that nature, because there was no substitution to be made in the first place. All right, so it was just you just had to know that you had to get rid of that denominator instead of using laws of indices, because if you did that, it wouldn't have facilitated solving via, well, as a quadratic. Sorry, 1 second, let's get some water. All right, okay. Yeah. Now, let's see. Is there a way that we could have used the negative index to facilitate the weekend. Wonder. All right, so let's say we had 2x to the 1 plus 1 is equal to 21 by x to the minus 1. Okay, so if we bring that across and we put it in its proper sequential order, right, so yeah, you can't factorize this like a quadratic. But you could factorize using x to the minus 1. Let me show you what I mean. So you could pull out x to the minus 1 as a common factor. And then what that means is you'd have to divide every term by x minus 1. Right? So what that means is, for example, you could completely, you could completely square if it's a quadratic. This form isn't a quadratic form, but it's a factorization. So yeah, so I know when the coefficient of x squared is other than 1 for a quadratic, to completely square, the convention is that you will factor out the coefficient of x squared from the entire expression, right? So it's similar in that particular respect. So if we divide by x minus 1, now laws of indices say what? When we're dividing and we have the same base, what do we do with the powers? We have to subtract. And when you minus 1, what does it become? It becomes plus 1. And 1 plus 1 will give us 2. All right. So we have there. 2x squared. If you divide this by x to the minus 1, it'll just cancel, leaving us with just minus 21. And if you take 1 and divide by x to the minus 1, well, as 1. Oh, okay, check this, right? So 1 is like 1 over 1. X to the minus 1 is 1 over x. And what's the protocol for when you're dividing fractions? Change divide to multiply and invert the divisor. Jonathan, if I got 42 and again 52.5, okay, that's interesting. I'll take a look at it again. But if you want, you could always you could work it out and send me like a picture on Instagram if you want, or email it to me. Right. So yeah, so then you get plus x. And of course, we'd just have to kind of scrap all of this. So 0. Then, right, so then what you could do here, you could put the x in the middle here and minus 21. This here would become like a 1 over x. So the x would simply become a denominator. And then you could actually just multiply throughout by x to again clear this out. And you're just going to end up with the same exact quadratic that we did down here, just in a way longer way. So yeah, it still didn't give us an equation. Oh crap! Yeah, reducible to a quadratic form per se. I mean, technically we did reduce it from here to here, right? But it just wasn't like a substitution. That's in broken English. All right, pretty good. Yeah. Okay. All right. So Luna, any further questions on this particular item? Oh no, sorry. I said Luna. I meant Shell Maurice. My bad. Oh, all right, cool. All right, Amelia, what about you? Do you have any questions on this particular item here? All right, cool. Okay, so the last one here was 7 to the power 2x minus 12 by 7 to the x plus 35. Okay, interesting. Okay. 7 to the 2x minus 12 to the by 7 to the x. Okay. So all right, okay, I'm gonna check Luna for a little bit and then come back and check you guys, right? Like how I have to consider it is like A is on top, so you're raising stuff, and B is equal to putting stuff down, so lowering value. So when you root something, usually you lower the value, right? And when you raise something, usually you increase the value. So yeah, it should be equal. Well, yeah, it should. Well, it is. Okay, well, let's root it as it is, right? So 7/8, 1/2, 2/2, fine. Right. So a half minus 2, right? 12 minus 1, then. Right. Okay. So what did that do there, guys? Well, right. But we'll look at one here. But you have the idea with respect to the other words. Right. And then now, hold on one second. Hold on. So I would see what are we doing? No, not you. Is a revision worksheet. Right? This is not the test. So what is this? It might be a worksheet or whatever. Right. Right. So right. So it's the same mistake you're making is so the -1 is outside, and you have 6 x cubed inside. So the index has to be applied to everything on the inside. So what we do is we apply the index to the outside. Right? Now if it's a common, it's 2. Right? And then when you're applying power, right, you have to apply it to everything in the bracket, including the second part. Right? But you have to write correctly here. A half of 4 plus 2. All right. So if you're multiplying, you add the powers, right? -2 plus -2 actually multiply. I think you multiply it again. All right. Again, so we'll come to it. Right. So look down here. Right. So right. So let me see if I can. So you have x minus 2 multiplied by 6 x cubed minus 1. Right? Now, another way you can handle the negative sometimes is just put them like this. Right? It might not be useful. You might not go back and do stuff anymore. Right? But if you put them like this, you could actually kind of multiply a little easier. Right? I mean, so of course, 1 by 1 is 1, 1. And when you multiply these two, the 6 is kind of a long way, right? X squared by x cubed. So when you multiply them, you have the same base. You just add the power. So you get 6, right? 5. Right? And then you're dividing by, so of course when you divide, so yeah, you could over it. And of course the other way to do it is to change divide to multiply and invert it. So what will happen here, right? And then you have 4 by over this, right? So 5, right? 6. Everything equal to equal. Right, 6 by 5 is 8, and x stay 5, but x is to the power 2. Same base, so when you multiply, you add. Yeah, so if the 6, if it was just like this example right here, and 1 2 3 6, then this would be enough as the answer. So this would be equal to everything inside the bracket, power on the top. Right? Okay. 10. Why is 8 7? That's a formula on there. 6. Right. Here, find. So 8 to the third is actually 2, right? So 2 cubes it, right? Okay. Move over like this. Right. Oh, you did stop there. Okay. Well, it still did something. So that counts. So let's see. Okay, one over 36. Right. So anytime you have a negative index, put in. Okay, take your cursor wherever you like. Yep. And it'll be 36. It's the easiest way to do it. And it will be. All right. So you want to use the word 1 to Okay, back. Oh, so this one was what I also did not want to do. So I don't want to say cheated, but let me put the example. Like I want to do it, right? So when you end up adding power, what led to that? It led to multiplying, right? For something in the same base, right? So we could actually split this into 732x multiplied by 731. Now, we could rewrite this like this. Because multiplying by 7 could also be done for multiplication. If it gets interesting. So you have 7 of these. And we did the second step here on itself, right? So if you have 7 of these and you're minusing one of them, what's that? When you divide by 6, what happens? Right. So that's going to be 1, which means that 3 I never saw that until I started to do this C square math. I saw that in the mostly within the last 2 years. Maybe like around maybe around 10 years. I keep saying 2 years. I keep forgetting to mean 10 years. I never go by the rule. That would make it a different thing. So let's settle right here. 8135 minus 4. Minus 1. So 34. Ah, remember this. 5. Yeah, because 81. Right, yeah, that's fine. 5. Again, good job. Minus 1. Okay. Okay, so let me subtract. Okay, so, okay, I see what you did. So 17 minus is pluses. And you're minusing this, right? Because you're minusing 10x and you're minusing 9. Okay. So whenever you're minusing, I'll say put a bracket that says minus 5. When you're adding, that's neither here nor there, right? Okay. So, okay, so minus 13 minus 17, that's 10 is 10 and minus 12. So it's 12. Okay. And 1/3 is 2 minus 1. No, actually, I wonder. Because, right, so it's treated this, right? Yeah, so if you want to equate the MC equal to minus 1, and then you can let this equal to minus 1 also. I'm going to call this, what is it? Yeah. Minus 17 minus 10 is 10. 17 plus 2 is 12, right? Yeah, and then you have minus 1 over here, minus 2 over here. Okay, all right, so you have a couple of instances. Now this one up, since this one is 34, and let's go back. Any other questions before I jump forward? No? No, people have all the marks. They don't know how many marks I get for it. Like, like, nobody gonna get that. We want to get marks for it. All right, cool. Right, sorry. Broken English is still there. With 14, it is 14,000. What? What do you want about, sir? I know it's not the man. All right, ladies. How are we doing there? Ready to take a swing at this or still working?
But I don't know how exactly
Okay.
like
All right, no problem. All right, so the first thing we're going to do here is we're going to express this as 7 to the power x, then squared. If you're not sure how I got that, let me know. I'll show you a slightly more detailed working. So we can see here is you have 7 to the x, then squared, and 7 to the x to the 1. So the power here, powers have the same relationship as a regular quadratic. So it's reducible to quadratic form. So we're gonna let's let y equal to 7 to the power x. Okay. So what this will become, therefore, is y squared minus 12y plus 35 equal to 0. Right? So 35 is quite easily factored because it's either 1 by 35 or 5 by 7. And we know 5 and 7 is 12. Right? But of course, it's a positive product but a negative sum, which means that they both have to be negative, as in y minus 5 and y minus 7. Again, feel free to do the longer version of the factorization. You might probably get more marks. I don't know. Right, now again, we come to a situation here that we've seen before. We're multiplying two things and we get 0 as the answer. The only way to multiply and get 0 is to multiply by 0. So we have to consider each of these equal to 0. And again, because y is a variable, right, we have to test, well, we have to check both of them. So if y minus 5 is 0, y has to be equal to 5. And same thing, if y minus 7 is 0, y is 7. Now, we're going to undo the substitution. Now, we have 7 to the x is equal to 5. 7 to the x is equal to 7, which of course is just 7 to the 1. Therefore, across on this side, x is equal to 1. On the other side, right, so that's going to take a little more working. Okay, so to solve that, you need to use logarithms. So what we could do is we could take logs, right, to base 10 on both sides of the equation. So log of 7 to the power x is equal to log 5. Using the power law, we can multiply the x to the front. Now to solve for x, we could simply divide by log 7. All right, let's take a look there. So log 5 divided by log 7 is about 0.827. So x is approximately equal to 0.827, correct to 3 significant figures. All right. Okay, so shall Marissa see how to finish it off there? Y'all didn't do logs as a topic? Oh, okay. So that whole part there was just like gibberish to you. Oh, okay. Right. Well, if you all didn't do logs, they can't expect you to know how to finish that question. I mean, you could keep plugging in values in your calculator, like 7 to like something is equal to that. That doesn't make any kind of sense. Right. So basically, I guess what you would do is just take one of the answers. That is very weird. If you guys didn't do logs. Good. All right. Okay. Well, if you guys didn't do logs, you don't have to worry about that piece. Just focus on this piece across here. All right. So just a basic piece of exam technique. If it's something you don't know how to do, then just leave it. Leave it and move and come back to it at some other point in time, or just move on and forget it. About X. Anyhow, different story. All right, cool. Amelia, any questions?
No, that looks fun.
Yeah, it's all right. They can't hurt you. Don't worry about it. Logs is just okay. Logs and laws of indices are practically the same thing. It's just that from the logs perspective, it's just you're going straight to the indices. But I could explain that next time. Which means, therefore, that your whole class had logs. As in, well, at some point in time, because I mean it's a topic on the paper, which also includes reduction to linear form, which is drawing log graphs. All right, okay. Well, obviously, you all wouldn't have to do that for tests, so we don't have to worry about that right now, but we do have to be mindful of it for May, June next year. All right. But we'll see when it's due, because when September starts, I have my own list of topics to finish May, June. Eh? Well, anyhow, we'll deal with that next time. Right. So logs is actually, you can teach any part of the syllabus at any point in time. There are certain topics which might be better left for Form 5 because of I don't want to say difficulty, but because it may be better to work other topics to kind of build up your foundation before you get to those. So for example, I would say you would need to work at least the quadratics aspect of the syllabus before you even tackle differentiation integration. I would even say you need to know at least a little bit of coordinate geometry before you go there. It's not absolutely necessary, but it's, in my opinion, preferred, right? Now, logs can be taught in conjunction or just after indices because that's all it is. Let me show you real quick, right? Okay, so let's say I give you 10 to the power 2 is equal to 100. That statement makes sense, right? 10 squared is 100. So this is what we call an index form. Now, let's say we didn't know what that was, right? Again, just for the sake of simplicity, right? Now, you know, like, for example, if we had, let's say, x plus 2 was equal to 5, and they wanted to solve for x, you'd simply, as they say, move across the 2. Or as I prefer to say, you'll remove it by using the opposite operation, which is subtraction, right? Now, you could do that with addition. You could do it with multiplication by using division. You could say, okay, if x over 5 is 10, then you can multiply. You could use basic arithmetic operations to solve most linear equations, even, most linear things, right? But when it comes to powers, how do we quote unquote transpose for a power? Now, if it's 10 squared, we could just find a square root. But if we don't know what the power is, how do we transpose? How do we make the power the subject of the formula? And that's basically what logs allows us to do, right? So the word logarithm shortened to log, right? So what it would do is it would put it in this form, right? Log to base 10 of 100 is equal to this. This particular phrase in here, this is simply another way of saying a slightly longer phrase, right? So for log, just imagine as the phrase, so what power do I have to raise 10? Have to raise, well, in this case, 10. Sorry, my writing kind of went. As I said, my penmanship sank, right? So I have to raise 10 to get 100, right? So all logarithms, as you can see, the log of that is this answer, and that answer is the power. The logarithm is the power, right? So logs and indices are the same thing, just by a different name, and just rearranged to make the index or the log the subject of the formula, right? So again, that's just a kind of by the way kind of introduction, right? So I don't expect it to be able to work out log stuff just by that alone, right? But it's just to show you that that's all logarithms are, right? It can seem pretty scary, as you said, because when you don't know how to do something, it looks scary. That's what I say. As humans, we fear the unknown, you know, or if we don't think we're going to get things right, or we think we're going to make mistakes, you know. But making mistakes is part of the process, so you just had to embrace that. Anyhow, philosophy will come back next time. Okay. So, Shell Maurice, what was the next thing you wanted? You wanted to work like more questions like that, or you had something else? So there's an alphabetic question here. You wanted to work that one? Oh, you mean like part B here, the definite integrals? Right. Here's my question, right? I noticed in part B, part 3, you have a definite integral there with limits in radian form, like pi over 4. You guys did like radians, arcs, and sectors. You guys know about radians? Okay. No, right. So, okay, you know how like on rulers, on one side you'll have like centimeters and millimeters, and the next side have inches. So you have different units of measure for length. Right. So with angles, the unit of measure you guys know is the degree. There's another unit called a radian. right? So which means that you guys don't know radians yet. It's on the syllabus. And just by the way, I cover that in October, right? As in I will be covering it in October, right? So I don't know how they want you guys to work number 3 in part B, because you have to substitute pi over 4 in place of x. Anyhow, we could discuss that next time. So, okay, so do you want to work some of these integrals? As in, you want me to work them, or you want to work them and have me correct them? Or how you want to approach it? Okay, so you want me to work, so like part A? Or part B, or the limits. Okay, cool, no problems. All right, so yeah, page 4 going here. Okay. You know what I could do? I could just keep. Right, cool. That's fine. Okay, but the first thing we have to do here is we actually have to kind of expand the brackets, right? So with differentiation is a product rule, but with integration there is not. At least not one that I know of. At least that's relevant to the CSEC AdMath syllabus, right? So the first thing we have to do is we have to expand 2x minus 3 by x plus 2. All right, so 2x by x is 2x squared. 2x by 2 is 4x. Minus 3 by x, minus 3x, minus 3 by 2 is minus 6. And of course, we could simplify the x terms. 4x minus 3x is just 1x, so just x. And then we have minus 6 as the constant. So now, right, when you're integrating, you'll integrate that expression. 2x squared plus x minus 6, sorry, dx. Hey, Delisha, how you doing? Good to see you on today. Yeah, sorry. Right, so when we integrate, what's the protocol? You increase the index by 1. So 2 plus 1 will give us what? That will give us 3. Whoops, sorry. And we divide by the new index. Sitting here, the index here is 1. When you increase that by 1, you get 2, and we divide by the new index. With the constant, technically it's 6 by x to the power 0, because that's 6 by 1, and then that's just 6, right? Right, sorry. So you're just going to get minus 6x. And I mean, you can put the constant, but it's kind of irrelevant when you're using integration with limits. Okay. So we'll just ignore that. Okay, so now when you make your substitutions, you're going to plug 3 in first. You're going to have 2 by 3 cubed all over 3 plus 3 squared all over 2 minus 6 by 3 minus 2 by 2 cubed all over 3 plus 2 squared all over 2 minus 6 by 2. All right, you with me so far? All right, cool. Okay, so 3 cubed is 27, but then it's divided by 3. That'll give us 9. 9 by 2 will give us back 18. 3 squared is 9. We have 9 over 2. 6 by 3 is 18, so that's going to cancel the first term there. We'll come back to that. 2 cubed is 8. 8 by 2 is 16, and then we have 16 over 3. 2 squared is 4. 4 over 2 is 2. 6 by 2 is 12. Right, and again, you can just plug all this into your calculator if you so desire. Now, 18 minus 18 is 0, leaving us with 9 over 2. 2 minus 12 is minus 10, 6. So we have 16 over 3 minus 10. So then that's minus 14 over 3. Again, so let me just double check that. 2 minus 12 is minus 10. That's minus 30 over 3. 16 minus 30 is minus 14. Okay, and you're minus in that. So 9 over 2 plus 14 over 3. When you're adding or subtracting fractions, we need a common denominator. 2 by 3 is 6. So 9 by 3 is 27, 14 by 2 is 28. So we end up with 55 over 6, which you can actually write as 9 and 1/6. But you could also leave it as just 55 over 6. All right, Shelman Reese, talk to me. All right, what about Amelia?
I was trying to figure it out on my own and then go back to see what you did.
Mhm.
When you started do default when you had 2x equals 3,
Mhm.
I was a bit confused on how you got that, and then I remember saying,
Correct, yeah. You increase the index by 1 and divide by the new index. That's correct. All right, okay. All right, okay. So that's the first one. All right. What about the second one? Do the second one time? Okay. Right. So that third one, if you guys did not do like trigs and radians and that kind of stuff, I do see how they could bring this for you. Do you guys remember like working anything like this in school? Radian. That's it. That was the long and short of teaching you guys how to deal with it. Wow. So these people, yeah, but that all right. Again, was that hook up over something I have no control over. Sorry, it don't make any sense to me to just tell you all that or even give you a small note without going into the whole thing. And that's why the sequence in which Holy Name approaches the AdMath syllabus to me makes no sense. But again, we have no control over that. It makes no sense again work up. So I'll show you all how to do it, right? But yeah, that was my thing. Like even a couple of years ago, I had a girl. I had Soraya. Soraya was what year? Boy, 2021, then 2022, right? And yeah, they started calculus like in term one. They did surds in the season log and then jumped into calculus. I'm like, how? Well, that makes sense. And then they did the same thing in 2023 as well. I'm like, what are they doing? Anyhow, again, nothing over which I have any kind of control. So I'm gonna hush my mouth. All right, so let's take a look and see how we would approach something like this, right? Okay, so the first thing we have to do is integrate sine 4x and sine 2x. Okay, when we integrate sine, okay, so hold on. There's the integral of sine of a linear function is equal to minus cos x plus b all over a. Right? Well, I guess you could put the plus c if you want, but it wouldn't make a difference with the limits, right? And then, well, there's only sine we have, but I'll give you a cosine one time, right? So the integral of cosine of the same kind of linear function. Now, please be aware that the integration, the kind of chain rule for integration only works with linear functions, right? As in, it doesn't work with quadratics, doesn't work with cubics, right? The only power of x inside that bracket is 1. Technically 1 and 0, but I mean, it's a constant. You can see that, right? So just be mindful of that, right? And here, so if we integrate cos, we're just going to get sine ax plus b, and then we have to divide by the derivative of inside, which again is a, right? And that's how we got the a here. Sorry, I didn't say that explicitly. So we integrate the function to integrate sine again minus cos, and because it's a function inside of here, you have to differentiate that and then divide by that derivative, right? So when we have the integral of sine 4x, we're going to get minus cos 4x all over 4. When you integrate sine 2x, you're going to get minus cos 2x divided by 2. Again, I like to put more constant, but once you're integrating with limits, I'm sorry, and then 0. Yeah, it doesn't matter because it's going to cancel anyway. Um, Solomon, I'm doing wrong for everybody. All your form files have it easy now. But yeah, remember to have other people in school too. Right, okay. When we substitute, right, so what's going to happen? 1 second. Huh? Right, so you're going to get the negative of cos. So it's 4 by pi over 4 all over 4 minus cos of 2 by pi over 4 all over 2 minus cos of 4 by 0, sorry, all over 4 minus cos of 2 by 0 all over 2. Right, now 4 by pi over 4 will simplify quite nicely to just pi, right? Because 4 will cancel with 4, so you have minus cosine of pi all over 4. 2 will cancel with the 4 as well, but you're going to get left with pi over 2. Right, 4 by anything by 0 is just 0. So you have negative of cosine of 0 all over 4. Now the interesting thing is that the cosine of 0 is not 0. So you have to know that. Which of course you all won't know because you all didn't do tricks as a topic. Anyhow, 2 by 0 is 0. And you have cosine of that. Right, so they said calculators in radian. Okay. Sorry, that's not a calculator. Hello. Okay, so radians. Hold on, just now. Yeah. Right, cool. Okay, so back to radians, right? Okay, so pi, and then I want the cosine of pi divided by 4, and I want the negative of that. So just, right? So the cosine, okay, so let me break it down a little more detail, right? The cosine of pi itself is minus 1. All right? Now the cosine of pi over 2 is 0. All right, so pi divided by 2, cosine is 0. You have 0 over 2 here. All right, again, so the cosine of 0 is just 1. Sorry, I didn't type that in. 0, so the cosine of 0 is 1, right? That's 1 over 4 and minus 1 over 2. And here it's just fraction work after this. All right, so minus a quarter is just positive a quarter. Well, 0 over 8, 0 divided by anything is 0, so that's going to just drop off. Now minus a quarter minus a half is minus 3/4. And when you minus 3/4, guess what? You minus a minus, you get a plus. And 1/4 plus 3/4 is 4/4, which is equal to 1. So all this lovely hullabaloo boils down to 1. Right. So like I was saying, just telling you to put your calculator in radian mode or giving you a note to me is not sufficient. I don't understand why they would do this. Set a paper covering a topic you all haven't done yet. I guess maybe the paper was either an old and the term they bring in for you all, and they were supposed to cover the material which it didn't do. And instead of leaving it out or blanking it out or telling you all disregard that, mark scheme done set, so you all have to do it. Right? Again, that's just me speculating. That mightn't be the truth. It might be totally far removed from the truth. But yeah, it's not new, and that's a surprising thing. You know? All right. So Amelia and Shelmers, I know you all might probably be in a little bit of shell shock. But let me know if you have any questions, because I had to give you something to work just now to go back and check Luna, right? Let me know what you're all thinking. What you're all Okay. Okay. All right. Cool. What about you, Amelia? How you feeling with that? Yeah, I would imagine. So what you probably have to do is just go like watch back. I'll send the link to the replay to Marie since she sent it to you. And you can just kind of go back over it step by step, piece by piece. And you can even ask her like how to use the calculator. You have a calculator, by the way. All right, you know how to use it. Indeed. All right. Well, I'm glad to hear that. All right. So you could whenever next to bounce up Shell Maurice if all this line, she could show you how to plug in stuff if you don't know how. Yeah, my calculator. Well, I bought one in January. After about 10 years of not having one because okay maybe 10 is still 2018 I think is the last time I had it, so about 7 years pre-pandemic. Every time I had calculus and I lent it to these kids and they went to do CXC well CSEC, I'd never seen my calculus again. So I'm like, well, I not bound for one. I could put up on the screen. Anyhow, so I bought one and I was also lent out to a student. Unfortunately, I got it back last week. Anyhow, um, so yeah, so here's my question: what can I give you guys to work? You guys want more stuff with limits to work, or you want to work 6A? Okay, so here's my question. Let's see. More limits? All right, cool. Give me 1 sec. It's not linked. I thought it was linked. Okay, 1 second. Let's see where 220 carries us. Okay, so not far enough. Ah, okay. Right, definite integrals. There we go. Okay. Oops. Come back down. There you go. Right. One, two, three, four. Okay, cool. Right. Okay, so this is quite a lot. This is like 21 questions, and I don't intend to give you all 21 to work unless you really, really, really want to. So let's keep it simple for now. All right. Okay. So hold on. No, right. No, not highlights. Let's let's do that batch. All right. So just so some slightly easy ones just to kind of get a feel for what you're doing. Oops. Hold on. Sorry. Right. Clearly, I want this. Okay, sorry. I tried to move that box and move. Right. So integral of x between 0 and -1, integral of 2x minus 1 between 3 and 0, integral of x cubed between 2 and 1. Okay, right. Okay, you're okay with those four? Or you want something harder to do? All right, cool. That sounds good. Yeah, all right. So we'll do that, and then we will try a couple more, like in L and N. We'll come to those. All right, let me go and check if we don't follow them. Oh, oh, okay. Oh, that's it? Okay, cool. No trouble. All we have to do now is bring in the A by x plus h. So let's do this one. Now let's see how we handle that. Okay, 2.
And why are you taking care of that?
Right. So this is something called convenience square. It was an answer. It was a way to help us solve problems when it could not be solved with factorization, right? And it's a nice long problem. And I know many of the students may be nervous and don't know that answer. We'll figure out now. 2. So long story short, now when you finish this session, I'll tell you, right? Because I do want to finish what I was doing. So long story short, if you were to expand this, okay, what is it now? What is that? You knew that? Yeah. Okay, maybe you draw a 6. That's okay. Let's just, because there was a time like now, I would mean and then I would reverse it differently, right? And deviations in mathematics are mighty passionate subject, right? The students talk about it, right? Okay. So keep in mind, when we wrote here, so we can test it for ourselves. You want to try? Deviation. You knew that fraction just now work like yes. Right, okay, we can even see. Right. Yeah. You say all the time, say, yeah, you can work it out. No, don't answer. Okay. No. This is interesting. Right. So the maximum or minimum point in the answer. The maximum or minimum point. The maximum, yeah. That's what I'm looking for. Now, again, all this is just kind of a help because we again, I do teach this in here. This problem, this here, right? But it's simply looking at minus h and q. So we have h is minus 3. So minus h is okay. And q Okay, you guys ready? Or only a few minutes again? Guys. Okay. All right, cool. No problem. Did I ask for that expression? What about it? No, that's because we get this from that, and that allows them to connect. To be completely square. No, sorry. Okay, sorry. Yeah, I forgot. I was on a timeout. Yeah. I like to show this stuff. Put it behind a matrix. Imagine we have a rectangle. And a rectangle Yeah, are you ready? Hi, yes, I'm back. All right, so you could, what are you gonna work now? What you gonna work on now? I didn't finish. Okay, cool. All right, so let's start. Integral of x. Okay, hold on. You know what I want to do? Let's hold on. Let's come back out. Wait, I'm at 800%. That's quite big. Okay. Can I delete that? Can't. I can. Okay, small thing. Cool. All right. Let's zoom back in here a little bit. Um, page 6. Okay. So let's get this one. Let's just take all, and we'll deal with them one by one. How about that? Okay. Yeah, that's fine. All right. Oh. Right. So B, right? B is the first one. So that's the integral. Oops. So between 0 and -1. Right. Okay. So when we integrate, what do? We increase the index by 1 and then divide by said new index. Again, you could disregard the constant because it's going to cancel off anyway. And then we have 0 and -1. Now, a little trick I could tell you, when you have a 0 as one of your limits, you could just ignore it. So Pauline says that the Talbot pure unapplied text. Yes, it is. Talbot. Talbot and Heng. Very, very, very good advantage. Right. So yeah, like I was saying, you could ignore or just disregard when you have to substitute 0. But let me be careful how I say that. Because what happens, long story short, is it just reduces everything to 0. Right, so of course 0 squared is 0, 0 divided by anything is just 0. -1 squared is 1. 1 over 2 is a half. And 0 minus a half is simply minus a half. Okay, how are we with our first one?
And when I
Oh, as in the middle here? Oh, okay. Right, well, you had a subtract. Okay, let's go back here. All right, option C. Oh, no, sorry, not C, is D actually. All right, so then this is the integral between limits of 3 and 0 of 2x minus 1 dx. Yeah, well, when 0 is your second limit, you could definitely disregard it then. Right, so we're going to have the integral of, right, so 2x squared all over 2, which will cancel just the 2x, sorry, x squared, and then x to the 1 over 1, which is just x, again, plus c, between 3 and 0, you can disregard that, right? So, like I was saying, let's do this substitution. So that's 3 squared minus 3 minus 0 squared minus 0, which is a waste of time. So that's why I say disregard when 0 is one of the limits, especially if it's the second limit, the lower limit. Right, now 3 squared is 9. 9 minus 3 is 6. All right. Okay, are we good with that one? All right, cool. All right, Shalmarie, how are we going? I hear you. Oh yeah. Yeah, that's when I saw her pop in on the next one. All right, small thing. Yeah, they could always give me a thumbs up. Cool. Thanks very much. Okay, so BDF. So F was integral of x cubed between 2 and -2. Okay, cool. X cubed, right? Yeah. Okay, so we have x to the power 4 all over 4 plus c between 2 and minus 2, disregard. Right. So now this will give us 2 to the power 4 all over 4. Sorry, one sec. Okay. Okay. Right, sorry. And then minus 2 to the power 4 over 4. This is going to cancel the 0. Because 2 to the power 4 is 16. 16 over 4 is 4. Minus 2 to the power 4 is also 16. Over 4 is 4. And 4 minus 4 is 0. All right. And last one for now is x minus x squared between minus 1 and minus 3. All right. So between minus 1 and minus 3 of x minus x squared dx. Yeah. Okay. So when we integrate, we're going to get x squared over 2 minus x cubed over 3 c minus 1 minus 3. Neglect that. Right. Okay. So we have some substitution. Right, so we have minus 1 then squared all over 2 minus 3 cubed all over 3. Wait, what am I doing? Minus 1. Sorry about that. Right, now we're minusing minus 3 squared all over 2 minus 3 cubed all over 3. All right, so minus 1 squared is just 1, so we have 1 over 2. Minus 1 cubed is minus 1. But when you minus 1, you get a plus 1. So we have a half plus a third. Minus 3 squared is 9. Minus 3 cubed is minus 27. Over 3 is minus 9. But when you minus, then you get plus 9. Okay. A half plus a third is 5/6. This is 27 over 2. Right. And of course, when you're adding or subtracting fractions, you need a common denominator, which is 6 in this case. 1, so you have minus 76 over 6, sorry. 38 over 3. All right, okay. How are we feeling with H? Questions, problems? All right, okay, all right. We'll zoom back in here. Okay, here, if you can get at least to the initial integral, you get some marks. Okay, so let's just give them a quick, oh, I forgot. I have a code for my online people. Yeah, so what I tell the people online, yeah, so you could send me, oh, sorry, I now seen your message here. Yeah, so I was telling if you're good with that, give me a G in the chat. If you need me to reaction, give me a R. Yeah. Oh, you give me a thumbs up. Okay, cool. Yeah. All right, Amelia, what about you?
I got to the part where you have a half plus a third
Uh huh.
but
As in for the final answer. All right, let me check it again. So a half plus 1/3. Right. So that's 3 over 6 plus 2 over 6 is 5 over 6. Right. 9 over 2 is 4.5. 9 and 4.5 is 13.5. Right. Then we have 5 over 6 minus 13.5. Okay. 13.5 is 27 over 2. Right. So we need a common denominator, which is 6. Right. So 6 and this 1 by 5. 3. 3 right. That's 81. Yeah. All right. Okay. So check it again for me now. Check if it did a calculator. Check it. See if you plug it in correctly. Because this would be like almost minus 13. This is like minus 12 and 2/3 or something. All right. So, quick question. You all want to work any more like this? We don't have too much time again. And I can't go past half past because I had to leave to do something. Um, so, seeing as we kind of in this particular, what you call it, subtopic, you all want to work. Uh, yeah, the signs are tricky. So even I get tired of that sometimes. So that's just a matter of practice, paying attention when you're working, and again, learning from your mistakes because they will happen, right? Um, all right. Let's just do one more, which is N. Okay, that's a little. All right. So that's the integral between -2 and -3 of 1 over x squared minus 1 over x cubed. All right. Let's pop in the check Luna for a couple of seconds and I'll come back and. So you have plenty of signs to get wrong here. So just take your time. So Come. Math is a work in process now. Well, some stress is necessary for us to grow. You have two types of stress. You have stress, which is stress, stress that you kind of like and want and kind of almost seek. And then you have distress, which is stress you don't really want. All right. So guys, let me see if we could sort this out. So the first thing we should do here, right, is actually rewrite this using laws of indices. And what I mean by that is that we're going to put this as x to the minus 2 minus x to the minus 3 dx. So now we could integrate. Okay, so when we increase the index by 1, we get minus 1, and we divide by that same index. Same thing here. When we increase minus 3 by 1, we get minus 2, and we divide by minus 2. Plenty minus signs going on here, boy. Okay, let's see if we can make some sense of it. So x to the minus 1 is 1 over x. So basically, that x would be you would flip it, and it would become minus x here, because you're going to multiply the x below. And then same thing across here. You're going to end up with 1 over minus 2 by x squared. We neglect that. And then you're minusing a minus. So what happens is it becomes a plus. So you have technically 1 over x plus 1 over 2x squared, which you could write, minus 2 minus 3, which you might probably prefer to write as 1 over 2x squared minus 1 over x. Right? So if you got that far, good job. If you didn't get that far, don't worry. We'll get there. Right, so now we can make our substitution. So we could sub minus 2 instead of that first x. So you have minus 2 then squared, minus 2 again. Minus 3 squared minus 1 over. So minus 2 squared is 4. 4 by 2 is 8. So you have 1/8. When you minus a half, you get plus. Minus 3 squared is 9. 9 by 2 is 18. Sorry. And when you minus a minus, you get a plus. 1/8. So half is 4/8. So we end up with 5/8. 1/3 is 6/18. So we end up with 7/18. What's the LCM here, boy? 72? Yeah, I think so. This is 2 by 2 by 2. This is 2 by 3 by 3. So we're missing 3 by 3 across here and by 2 by 2. Okay. Yeah, so we get 72. So we get 45 over 72 minus 28 over 72. 45 minus 28 is 27 over 72. Those are both divisible by 9. So you get 3 over 8. I'll go into my little technique down here next time. Anyhow, ladies, I had a cut and run there. All right, so I hope this was helpful in some way, shape, or form. All right. The next day for AdMaths here should be Tuesday, right? But I know exams are near, so when exams are near, the timetable kind of gets thrown out the window, and people just come when they need to come, right? But I need to know who's coming and when. All right, so let's Tuesday, can we do math instead? What during the 4 to 6? Are you coming in person? Okay. When is the math exam? Do you know? But math is Wednesday. Oh, okay. Well, actually, that's the fact. And the boys have their math on Tuesday, so I'll work in maths with them Monday. So they might be here for the 6:30 to 8:30. I'm not sure. So Shelmaris, if you want to come Monday and Tuesday, we could. If you have stuff Monday, going on Monday is not a problem. But let's stay in touch on WhatsApp this weekend and firm up plans. So because we could do Monday and Tuesday, we could do a double on Tuesday. We can figure it out. All right. Okay. Well, going for now. So have a good evening. So bye, Amelia. Nice to meet you. Hopefully see you next time. All right, bye. All right, bye, Sean Maurice. I'll see you too later. Okay, cool.